hey, I'm gonna try to add zero size types to K1. So right now I do have a unit type, but it takes up 1 byte and we never check the value. And that's not right. We need a zero size type. For one, to model C's void for FFI, it's very convenient to have a type that maps to what Clang and GCC are gonna do for void for C code, because like first class interop with C without adding a bunch of annotations is a major goal of mine with K1. So yeah. And then another goal, zero size types enable some nice type level trickery or machinery. Some of it I'm not really in love with, a little bit of type level programming, which you can get into a lot of trouble with really quickly, I think. Getting a bit too clever and a bit too clever and not wise enough. But when you have types that take up no space, you can tag things with a certain type. You can include a phantom data on a struct member, which is what Rust does to track generics when there are no types that contain the variable in the type. It's definitely a workaround for like a. You can fix that a different way, which is to just have the type remember where it comes from. But yeah, like Rust's phantom data. What else? You can just have a type that's parameterized by like effectively a Boolean trait that has like open and closed, and then you could like have a lock. Like you can do a little bit of. Oh, there was a thread going around on Reddit the other day, like on Rust. Called it like type state. Yeah, they were calling it type state. And I first encountered it in Scala, actually using type variables and for nothing but like tracking some type level state, and it's kind of cute. There can be some useful things for it. I did an example for my team where I had like an open door and a closed door. Ended up using it for like an encrypted and decrypted data, but it was all like a little bit heady and probably not solving too many real problems. But yeah, that's my little spiel on getting too clever with type level programming. But having zero size types is super useful. There's also the classic Rust trick with the hash map where the value is unit, and suddenly now it's just a hash set, which I think is at best cool, honestly cute, at worst like useless. Like, I don't know, you could just write a little bit of code and not need that. But I'm pretty certain that there are other places that having zero size types is quite a useful thing. So we have to think through a few things. How do you write them? What do they look like in the source language? Do we have unit? My plan is actually not to have unit. My plan is to get rid of it as part of this. Let me just open up my a.k1. So right now we have like let x is of type unit and it equals. So the type syntax is writing the word unit and the value syntax is the empty pair, which if you've done functional programming, you're like, yeah, this is awesome. This is what I know and love. This is super familiar. That's unit. Or if you've used Rust, right? But if you take a step back and like imagine you're teaching a beginner programming and you tell them, yeah, there's this thing that's nothing and it's called unit. Like what unit? Like feet or pounds? Meters, right? No, it just means like the unit type. It's just like unit, like it just comes from math. Okay. And how do I write it? Well, you write the word unit. Okay. And I could fix this by doing that, right? And it'll be a little bit more consistent. But for now, it's like, okay, you write the word unit. Or you write an open paren, closed paren. It's like because there's nothing in there. Okay. And then in the value side, you also do open paren, closed paren, which you usually do for grouping expressions. What, right? So this thing already has a meaning. Minus is a bad example. Let's do this. So it's useful, right? I think. I don't know. Who cares? But looking at this, sorry, completely lost my train of thought here. Right, so unit already has a meaning, which is to group expressions. So what I would expect is if I don't put anything here, that this would be invalid code, but it actually, no, it's a literal of this wholly different type that's got nothing, or like there's only one instance of it, technically. It is inhabited by one value, which means the value carries no information. Like, all this stuff you'd have to teach, and it's valuable to know, like the difference between never and unit, dead code. Like, never is important because it has 0 inhabitants, right? Which means you'll never have one. So if something says it is one, then that means you can't get there. And that's useful for control flow analysis for this concept of never finishing or exiting. And then unit is inhabited. There is one value of type unit, which means I can always produce it. It requires no information to produce a unit. And because it requires no information to produce, it also carries no information, right? And then the next thing up is bool, right? And that is inhabited by 2 values, true and false. And that carries information. It carries exactly 1 bit of information. And then we don't have a special word for the next one up of 3 bits of information for triple. Maybe there is. Maybe there's some like ternary computing systems that like make heavy use of it. I've never used them. I feel like there might actually be, because this idea of maybe is kind of very useful. You have like, you know, false, true, and possibly. But anyway, I'm just talking random shit now. The point is that this is hard to teach and out of place, even though it's a valuable concept. The concept of an inhabited type that carries no information and has no size is really useful. But calling it unit, and one last thing, I don't have tuples. So I can't write, I don't have like anonymous tuple, like pairs in this language yet. I'm considering adding them. I'm considering adding them in a way that harkens to structs, where it's clear from the syntax that this is just a struct where we didn't name the fields. So the names are just positional. But I really don't like tuples. I love them mathematically, I get it. But I think you almost always want names. Names are like superior to positions for humans to reason about. Just very classic positional arguments. I have a function that takes 5 integers, right? We all know that's worse. Do math for -3, 21, 17, false, right? We all know that this, performance or characteristics aside, base, offset, no, coefficient, level, log. We all know that that is better because names are like superior to positions. I can't look at this and just immediately see 4. It's 4th. I can look at this and immediately see level, right? So there's just this amount of information being conveyed that's better. So when we use tuples, we rely on positions, and it works at 2, and it even kind of sometimes works at 3, right? But, you know, it's just, let's do another rant. It just starts to become a problem past a certain point, right? And you're like, you know what? I wish I had names. So I'm not sure that I'll ever add tuples as such to this language, because I'd like to take every use case where you want to reach for a lightweight tuple and make it really easy to reach for a lightweight struct. Having anonymous structs, you don't have to provide a name. I feel like it solves 95% of the reason people reach for tuples, which is that I don't want to go up to the top of the file and declare a class with like 2 fields or declare a struct. I just want to say it right here. Like I just want to say 2 of them, and it feels really good. This feels very expressive, and I don't want to give this a name. It's just the pair that main returns, right? Well, in K1, we can do this, right? We can have an anonymous struct, and it is just as efficient and static as if we had declared it up here. So yeah, my plan is to design around the need for tuples. And if we don't have tuples, then having the empty tuple be our encoding of unit doesn't make sense. But having the empty struct be our encoding of unit actually makes a lot of algebraic sense. Because all I did is I took the struct that you've been using the whole time that you've been programming in K1, come back to the numbers later, and I just said this one has no fields. And that makes sense. I can start with a struct with 2 fields and then remove one. It's okay. Now it has one. A struct with 1 field, that's interesting. It's basically just the field, which is like a 1 tuple, right? And then, oh, what if I had no fields? Well, I can always make an empty object because I need no information to make an empty object. And I can write the type the same way that I would write the type if I had fields and just not include any. So we get all the nice symmetries that we do with unit by doing this. So my plan is to remove the word and the type unit from K1, make the empty struct work everywhere, make it work well, make it have size 0, which it already does. I hardcode unit to have size 1. Empty struct, I think, already has size 0. So we already technically have a 0 size type, but we don't handle it correctly, especially down in like the physical layers of the code. So like the bytecode generation, the LLVM layer, and the VM. I think that's all I have to say for this intro. Thanks for watching. Hopefully you maybe learned something about types or found this to be like a useful analysis walkthrough. Again, and this is the upfront plan, and it may not go that way. It may turn out really bad, and that's where the process of building is so valuable together with thinking and planning, because once your ideas come in contact with the rest of reality, sometimes you change your mind, or often you change your mind. So, but that's my plan. That's where I'm going, and I'll probably record some work sessions on this and post some updates to see how it goes. But I kind of like to share the process of a change or a feature from inception and plan through to the end. So stay tuned.